Let's have a look at this question. So question 1 in the 2018 paper on paper 2 kicked off with this. The diagram below shows a circle with centre 0 or O. The 5 points A, B, C, D, E are on the circle. A, B and D, E are diameters of the circle. So A, B and D, E are diameters. And a diameter of a circle is a line that goes from one side of the circle through the other and passes through the centre. And the centre is the O in this case. And the angle BOE, so BOE, so always go to the letter in the middle, so O is 40 degrees. The angles XYZ are labelled. XYZ. Okay, write down the size of the angle X. Okay, so continuing on basically with all the theory we've been doing on geometry, can you see our X here, okay? And if you remember from our theory, that X should tell you that X is equal to 40 degrees. Why? Always remember, you need to write down the theorem, you need to write down the property that tells you why you're writing down this, okay? It's not about the maths in this chapter, it's about understanding the proofs and the statements that are surrounding geometry. So vertically opposite angles are equal. Okay, so X is 40 degrees. And once you know these statements, it is that easy to collect whatever marks was for that question, whether it was 5 or 10 or whatever. Okay, so that was the angle X, okay? So I'm going to rub out these markers now, and I'm just going to put a little 40 degrees in here beside X, okay? So this angle here is also 40 degrees. Work out the size of the angle Y. So Y is down here. Okay, so with a bit of practice of geometry and circles, I suppose the circles piece of geometry, you'll know to always look out for radius, okay? So anywhere from the center out to the edge is the radius of a circle, okay? From the center out to the edge. So a radius is half a diameter, okay? So all of them are radii, which is the plural for radius, okay? And because they're all radiuses, they're all equal in length, okay? Which means what? Well, when I look at this triangle here, okay, I see a triangle now with 2 equal sides. And that should tell you that that's what we call an isosceles triangle, where 2 of the sides are equal in measure. And also in an isosceles triangle, 2 of the angles are equal in measure. And just like so, this would be an isosceles triangle over here. Okay, so if I draw that triangle up here, okay, maybe I'll draw it in the same direction that's here, so straight line. Okay, so that's the point O, that's the point D, and that's the point A, okay? So in here, I have 40 degrees, okay? And I have 2 sides that are the same. So angles in a triangle add up to 180 degrees. Okay, so 180 degrees minus the 40 degrees that's already that angle at O leaves 140 degrees, okay? Why 180? Angles in a triangle equals 180 degrees. And you can see I don't write out big long sentences, but I do state the theorem that I'm using or the property that I'm using, okay? So 140 degrees is the amount that's left for the other 2 angles when we subtract off this one. So because it's an isosceles triangle with 2 equal sides, these 2 angles are also equal in measure. Okay, so that's why we can go 140 degrees divided by 2 is equal to 70 degrees, which is equal to that angle Y. Why? Isosceles triangle. Base angles are equal. Okay, so y equals 70 degrees. Okay, x is equal to 40 degrees. Now work out the angle z. So finally with the angle z. So I clear off the diagram again, okay, because this time I want to draw your attention to the what's called four-sided shape here inside a circle. So it's called a cyclic quadrilateral. Quadrilateral is a four-sided shape. Cyclic refers to the circle. So you can see that that quadrilateral is within the circle. And when you place it inside the circle, you force the angles to be a certain size. So angles in a cyclic quadrilateral add up to 180. So opposite angles in a cyclic quadrilateral add up to 180. So opposite angles in a cyclic quadrilateral add up to 180 degrees. Now in many quadrilaterals, opposite angles are equal in size, okay? Not so with cyclic, but they do add up to 180. So that means I need to know this angle here. So to work that out, can you see that you have a 180 degree angle there? Okay, so angle at O is 180 degrees minus the 40 degrees, so it's 140 degrees. So this is a 140 degree angle here. Okay, and I'm going to just put straight angle there because that's where I got the 180 degrees. Okay, so therefore, that's maths language for therefore, Z is equal to 180 degrees minus 140 degrees. So it's equal to 40 degrees up there at Z. Okay, and the reason for that is what I wrote in black. Okay, so a nice little question there, really tested that you knew your theorems, which is very important in the junior cycle.